Hey guys, welcome to the solution video for WriteUp 8, which was the first write-up where you had to write a visitor for pstruct. What we need to do for this visitor is we need to add all the members of the tree to the hash set which is passed here as the second argument. Before we dive right into the solution, I had a few notes on pstructs that might be helpful. So just like the ls struct, each pstruct has a state. It can either be in an empty state or non-empty state. The methods that we tend to use generally, get datum, get left, get right, are only valid in the non-empty state, which makes sense because if you have an empty tree, you cannot have a root, you cannot have a left child, and you cannot have a right child. So if you try to call those methods on an empty tree, you will get an illegal state exception. The only method you can really use on an empty tree is the insert root, where you pass in a data value to your method insert root, which would insert that particular value at the root of the tree. And obviously the tree would no longer be in an empty state because it does have a root now. And the other method that we really use is get datum. A lot of people think that get datum returns another pstruct, but no, get datum returns the root of the pstruct, which the return type of the method is the type of data stored in the pstruct. So if you had a pstruct of integers, getDatum will give you the root of that tree, which is an integer. So you cannot use calls like host.getDatum.getLeft because basically you're trying to call get.getLeft on an integer, which isn't valid. Those methods are only valid for pstructs. GetLeft and GetRight, on the other hand, will give you pstructs. So GetLeft will give you the left child of the pstruct, and GetRight would give you the right child of the pstructs, where you can call methods like getDatum and getRight. So let's jump right to it. As Isaac mentioned in his write-up solution for LR struct, it is always easier to start with the empty case, and it will eventually help you solve the non-empty case as well. So if we have an empty tree, there's nothing really we can add to the set, right? So luckily for us, this is already done because there's nothing we need to, we don't need to alter the set in any way. As for the non-empty case, the first thing you would want to do is you want to add the root of the tree, which you can get by host.getDatum. But we aren't done yet. We haven't added all the members that are in the left and right children of the host. So many people do something like, sorry, I wanted to use add. Host.getLeft.getDatum and host.getRight.getDatum. The reason why this doesn't work, and we can confirm that if you run the test again, the reason that this doesn't work is, first of all, you don't know whether the left and right children of the host even are non-empty. Consider this example. The only thing in the pstruct is the root 5, and the left child and the right child both are empty. So if you try to call getDatum on empty trees, that will give you the illegal state exception that I was telling you about. So you cannot use this as a solution. The other problem is if you have a big tree, this is not exhaustive. The only thing it does is it adds the root and the root of the left child and the root of the right child. It doesn't add anything else. So we can't use this. What we really want to use is we want to use recursion and call this visitor on the left child and the right child. The way to do that is you get the left child using host.getLeft and you execute the visitor on it. So you pass the same visitor, and don't forget to pass the set, which we've been using, as the second argument. And you want to do the same thing for the right child. Note that the order of these two statements doesn't matter as long as you're adding it to the set, so you could have interchanged it without any impact on the result whatsoever. So if we run the test again, hopefully things should pass. Okay, there you have it. That was the solution for the write-up. Now let's try to walk through this using an example. So again, I have a BR struct of integers, which is slightly bigger than that one. And when we execute the visitor, we start here, and the entire tree, that is our host, right? And we will run the non-empty case because, well, this tree is an empty. The first thing we do is we add the root of this tree, which would be 5. So at that point, we have added 5 to our hash set. The next thing we do is we get host.getLeft, which is this BR struct, and call execute on it. When we do that, we are running the non-empty case again, but this time we're running it on this BR struct. So this is our new host. When we do that, we add the root of this host to our set. So now we've added 5 and 7. And then we try to get the left for this host, which is an empty tree, and try to call execute on it. So we will be running the empty case now, which does nothing. The next statement that we have is host.getWrite.execute, which is again empty, and we add nothing. We finally exit that. Using the return statement, we finally exit that call and go back to our main call. And after getting done with this line, we move on to the next one. We get host.getWrite, which will give us the write child, which is again a BR struct, and we call execute on it, which will run the same visitor on this BR struct. Again, it runs a non-empty case because the BR struct isn't empty. The first thing we do there is we add the datum. So we have added 5, 7, and 8 now. And when we call host.getLeft.execute and host.getRight.execute, this will run the empty case because the left and the right child, the children of this BR struct, are empty. So that does nothing to our set. And at the end of that function call, we are done with the visitor, and our set contains 5, 7, and 8 exactly as we want it. So there you have it. That is the code for WriteUp 8. If you have any questions, please post them on Piazza or come to office hours, and good luck for the next WriteUp.